Okay. I want us to investigate a little bit. So quickly find me the gradient of AB, the gradient of DC, the gradient of the line EF, and the gradient of the line GH. So I will highlight the points for you. There's A, and there's B, and there's C, and there's D. There's E, and there's F, and then there's G and H. Now, I want you to work out the gradient for each of these lines. And when you're done with that, tell me done in the chat. And we're just going to start with that today. Now, if you've forgotten the formula for gradient, it would just be that, the change in y over the change in x. Yeah, so we're finding all of these, and the first one, AB, so I would go -1, -2, and then 1 minus -5. So this is -3 over 6. And if I had to actually, if I had to simplify that, I could simplify it even further, and that would be -1/2. So we have got -1/2 as the gradient for that. And then what is the gradient of DC? I'll give you some time, and then you just tell me in the chat when you're done. So DC would be 3 minus -3. And here would be -1 -4. And that would be 6 over 3, which would be 2. So the first gradients that I get are -1/2 and 2, or 2 over 1 if you really want to be sneaky. Now you still need to find me the gradients of EF and the gradient of GH. It's EF. So what I get is I get that the gradients for A, B, and DC are not the same, but the gradients of AB, let's have a look, let me highlight them. The gradient of AB is -1/2, and the gradient of EF is also -1/2. So let's go and find those. So there are two that are the same. And what do we notice about the line EF and the line AB? This goes going back to the last lessons. I'd love someone to put their hand up and tell me, or to kind of tell me in the chat, what do you notice about those yellow lines when you look at them just visually? Who has some knowledge to share with classmates, either in the chat or... They have the same gradient. Yes, they have the same gradient. And what we also notice is that this and this line are parallel to each other. So if something has the same gradient, they are parallel to each other, which is awesome. Now, instead of focusing on the relationship between the yellow and the yellow, let's focus on the relationship between the yellow and the green line. Now, they are not the same, but they are related to each other. We would say that they are negative, or let me even show you this. If I multiply AB times DC, the gradients of those two lines, I go minus a half times 2 over 1. And when I multiply minus half by 2, what do I get? When I multiply 2, so the green one, by the yellow one, what am I going to end up getting? The 2's cancel out, and I get minus 1. And so this is something that is really important for perpendicular lines. When you have perpendicular lines, when you multiply the gradient of perpendicular lines, you will always get minus 1. You will see the same for the second two over here. If I multiply the gradient of EF by the gradient of GH, I'm just getting minus a half times 2 over 1, which is minus 1. So we say when lines are perpendicular, you can multiply their gradients to get minus 1. But a quicker way to use this idea is, if I tell you one line has a gradient of 3, and I want to know the gradient of a line that is perpendicular to that, instead of having to multiply and stuff, all we do is we switch the top and the bottom. So 3 over 1 would change to 1 over 3. And then if it was a positive, it becomes a negative. So if lines are perpendicular, we say that they have, I'll put this down, you can write it down. Perpendicular lines have negative reciprocal gradients. And that's a fancy way of saying, if I have two lines that are perpendicular, then if I have the one gradient, in order to get the other one, I just flip it over and change the sign. And it won't be the same, but it is easy to get the one from the other. And even if we check this out to see what happens if we multiply 3 by minus a third, what do we get when we multiply 3 by minus a third? Okay, we get minus 1. Yeah, and that's what we expected because we know these are perpendicular lines. So the first bit of key information for today is that parallel lines have the same gradient. Perpendicular lines have gradients that multiply to give us minus 1, or gradients that are negative reciprocals of each other. So give me a score out of 10 for how well you understand that idea. So 10 if you get those ideas perfectly, 0 if you don't get the ideas at all, and 5 if you sort of get them but not super well. This is the main idea for today, and the angle of inclination. That's the two main ideas. Okay, so let's go to this question. Okay, it says the line L, let me actually zoom right in on this so we only focus on this. It says the line L passes through minus 4 naught and 2 minus 2. So let's give it a different color. We'll call that the yellow line. And then there's a green line called M that passes through those 2 points. And the question is, are the lines L and M perpendicular? Now, I want to know from you, what do I really want to know about these lines if I can't see them visually? What do I need to work out for the yellow line and the green line to try and figure out if lines are perpendicular? Let me know in the chat what you think I need to work out in order to do, okay, I see in the chat people are saying, they are screaming it, gradients. So I want you to work out the gradient of the yellow line, and I want you to work out the gradient of the green line. And then I want you to tell me, do you think these are perpendicular lines or are they not perpendicular? Over to you guys. I want you to do the work here. Keep those answers coming in. Do we think L and M are perpendicular? Put your answer in the chat so that we can all learn together. Okay, so line L and line M are not perpendicular, and the reason they're not perpendicular is that I'll say lines do not multiply to -1. Okay, so if you multiply 6 by -1/3, you do not get -1, and so they are not perpendicular. Okay, that wasn't so bad. I think Nomfundo agrees. Okay, now let's do another type of question. I want to know, write down the equation of in fact, not even that one, let's go. Write down the equation of the line that is perpendicular to this line, but also passes through the point 0, -1. Now, you're going to need to use ideas that you learned in previous lessons, so that if anyone is here and wasn't at a previous lesson, ask me a question. But I think you can start. So you need the equation of a line that is perpendicular to this one over here. But your other one also goes through the point 0, -1. So I want you to tell me in the chat where I should start, and then I want you to start doing it. Maybe a good place to start is, what is the gradient of the perpendicular line to the green one? Yes, I think I see a hand up there. Bukle, what do you think the gradient of the perpendicular line should be?
The gradient is a half, sir. So we can take the half and insert it into the formula to find whether the two gradients are perpendicular, and then we can get the other gradient of the other line.
Now, so I'm hearing you say use the straight line formula. What I want to know, Bukle, for the yellow line, which is perpendicular to the green one, do you know what the gradient is?
Yes, so it's a half.
Okay, I disagree because...
Wait, sorry, wait.
Yeah, it's fine.
Sorry, I'm busy talking about the green. Jeez.
No problem. So can you see that perpendicular is the relationship? So you're right, the green one's gradient is a half. But what is the gradient of the yellow one going to be?
It's going to be -2.
Yes, perfect. So what you do is you flip the 2 and the 1, but then you need to change the sign. And so what you've got is this situation, and now you guys need to use 0, -1. So what is the equation of the yellow line going to be, people of grade 11? Okay, so pop your answer in the chat. I see Callan -2, Sasipo -2. I like it. Now, what do you think the C value is going to be? Well, I can take this point, and I need to sub it in, don't I? So I think I'm going to put a -1 here, a -2 times 0 here, and then I get C. But actually, the 0 knocks everything out. So C must be -1. And then my final equation must just be -2x -1. And so that is going to be the equation of the yellow line. That's going to be the equation of the yellow line. Very nice, Pilar. Very, very nice. I like it, Sasipo. I like it. Okay, I feel like you guys are doing well here. I want to try this one. So write down the equation of the line that, in fact, no, that's too easy, I think. That's too easy. I want to give you a harder one. You guys are quite capable of doing this one. So determine whether the line with the equation 2y plus x equals 1. So determine whether the line, the yellow line, determine is it perpendicular to a line which goes through these 2 points. Now, this is a little bit harder, but remember, what are they asking? They're asking, are these 2 lines perpendicular? So what do you have to find? You need to find the gradient of the yellow one, and you need to find the gradient of the green. So I want you to try and tell me what is the gradient of the yellow and what is the gradient of the green. Over to you guys and girls. How could we get the gradient of the yellow one? Pop it in the chat if you feel like you understand. Okay, so green for the yellow standard form is the way to go. Bukle, you're giving us some good advice here. So at the moment, the reason I can't see the gradient is I need it to be in standard form. And Sasipo has said, I think yellow is -1. We're going to find out now. Naledi has said, with yellow, don't we divide them all by 2? Ooh, that's also an interesting idea. There's a couple of things we can do. But I think what I'm going to do is I'm just going to move the x to the other side, and I get -x plus 1. And then I'm going to do what you said. I'm going to divide both sides by 2. And then I get y is equal to, now this is where I have to be careful. There's a phantom -1 in front of the x. So if there is a phantom -1 in front of the x, what I'm going to get is -1/2 x plus 1/2. So the gradient of my yellow one is actually going to be -1/2. So that's going to be the gradient of the yellow one once I put it in standard form. But what is the gradient of the green one? What is the gradient of the green one? 4 minus 5. 4 minus 2. I get -1/2. Are these lines perpendicular? Are the yellow and green lines perpendicular? Careful, this is a sneaky one. I'm so sneaky. So the gradients are the same, but if the gradients are the same, it does mean something, but it doesn't mean they're perpendicular. Okay, so what it means is the lines are parallel, and therefore not perpendicular. So the lines are parallel because they have equal gradients. But remember, the question was asking, are they perpendicular? If they were perpendicular, the one would be -1/2 and the other one would be +2. Okay, so we can ask these questions in different ways, but that was mainly just a sneaky way of doing that. All right, let us do, I want you to find, okay, so in each of these questions, you have to determine the equation of the line passing through. Let's do one where it's parallel. So you need to do that one. And then you also need to do C, where it passes through the green point and it goes through there. So let me actually highlight the ones you need to do. You need to do C and you need to do B. And I want you to try and find me the equation of the line that goes through 3, 2 and is parallel to this line. And then I want you to do the same for C. So off you go. You let me know if you have a question. I will monitor the chat. But I think you guys can fly solo for this for now, unless I see some questions. Oh, my door doesn't seem to want to unlock at the moment. Oh, well. So did y change to -1/2? Let's have a look. So when the x went across, it became a -x. Yeah. So let's see what we get for B. If lines are parallel, they must have the same gradient. And since the gradient of this is -2, the gradient of the line I'm looking for must also be -2. And you need to then use the point 3, 2 to help you find what C is. So I'll wait for your answer in the chat as to what you get. If you've got the answer for B, you can go on to C in the meantime. Okay, so for B, I get -2x plus 8. See if you guys can do C now. Now, C is going to be slightly different, but there's going to be parts of it that are sort of the same. And what I want you to do is tell me when you're done with C, and then I'll mark it. But I'll give you a bit more time for that. Oh, your line keeps going out. Don't worry, Anushka. That's fine. There is a recording. So if you've got choppy internet today, remember you can always watch the recording if you've missed a few bits and pieces. So let's have a look. I think the gradient of the line that I'm looking for will not be 3. It will have to be -1/3x plus c. Now, the point I'm going to use is going to have to be this. So I'm going to wait a bit more time before people start saying done, but I want to see done in the chat before, from a couple of people before I answer it. So we'll take the point -3/4 minus 4. I plug that into this. Now, I do have to watch out for my calculator here. So -3/4 minus 4. Okay. So what I now do is I suppose the 3's are going to cancel. That's quite nice. The positives are going to cancel, and I'm just going to get 1/4 plus c. And then when I bring this across, I get -4 1/4 equals c. Or you could also say that your calculator might say it as minus 17 over 4. And I quite like that. It's a bit easier. So you should get, for your final answer, minus 17, well, minus 1 over 3x minus 17 over 4. And that is the perpendicular line that they were asking for. Okay, give me a vote out of 10 or how you feel about finding parallel and perpendicular lines, where 10 is perfect understanding, 0 is nothing, 5 is sort of okay, but still needs some improving. I want to see from the group. It helps me understand how quickly I can go and what pace I should go at. And be honest, because that's the only way I can judge how you're feeling. Okay, and if I am going a little bit quick, remember that by tomorrow, the recording will be out and you can re-watch parts of the lesson, or if your internet was bad and you were losing me. All right, everyone, then it's time for our halftime break. And so what I want you to do is I want you to turn on your cameras and I want you to join me in standing up. We take this break because we know it helps our learning. And so all I want you to do is I want you to stand up with me and just take 3 quick deep breaths. Breathe in. One more deep breath. Okay, then I want you to shake out your arm like you're in drama class. You want to be nice and loose. You want to loosen up your legs, shake your legs out. And you just want to be as relaxed as you can be. So just go to whatever happy place you go to, and then you can just roll your shoulders back to, in case your shoulders are feeling tense, roll them forward. Okay, and then let's do a tricep stretch. And then on this side as well. Nice tricep stretch. That feels good. And then just shake it out one more time. So shake out the arms, shake out the legs. And then we are just going to do some heart rate stuff. So we're just going to do 10 jumping jacks like we always do in 3, 2, 1. Let's go. 2, 4, 6, 7, 9. 2 more bonus ones. 11, 12. Oh, and I can feel my heart rate definitely got up a little bit there. And then a brain break. So here is today's brain break. Can you tell me what a triangle minus a star is going to be equal to? See if you can solve that problem. What do we think it is? Oh, I see some messages coming in. So 4s and 2s are definitely involved. Well, if that was 4 and that was 2, if that was 4, no, but that wouldn't work. So it can't be 4 and 2. Maybe what it could be is 2 divided by 1 is 2, but 2 times 1 is 2. So what is 2 minus a star? Sylvester, I think you have done it. It is a 1. Okay, that was actually easier than when I first saw this, I was like, what's going on? And now I actually see it's not too difficult. So that is our puzzle for today. All right. Now, how is your concentration feeling? We're going to start the second part of the lesson, but I want a quick feel for, give me a number out of 10 as to how you're feeling about your concentration going into the second half of the lesson. 10 is perfect concentration, 0 is no concentration. Put a number in the chat. All right. So in the second half of today, we are going to talk about the angle of inclination formula. But before we do that, I need to explain to you what the angle of inclination is. So if I have a positive gradient like this, let's say I have a straight line like this, the angle of inclination will just be this angle here. Basically, what sort of angle do I need to get to turn from here to here? But if you have a straight line with a negative gradient like that, well, then your angle of inclination is going to be this big angle over here. Now, what you'll notice is that when you have a positive gradient, you seem to get an acute angle or an angle smaller than 90, whereas when you have a negative gradient, you should be ending up with an obtuse angle for that visually. So this is what we call the angle of inclination. And there is a relationship between the gradient of a straight line, okay, the gradient of a straight line, and the angle of inclination. So if you know what the gradient is, you can work backwards to get what the angle of inclination is. And all that we need to actually do is to realize that there is a right-angled triangle here. So let me try and bring that thing back. Okay, where did it go? It left the building. So if we think of this angle, we can think of the gradient as being, let's say, run over rise like that. Okay, I know that's a little bit messy, but let's try to find this angle here. Now, we can think of the gradient as being how much do we go across and how much we can go up. But there's another way that we can think of this, and that is as O, A, and H. Now, what does O, A, and H remind you of? What section of work does O, A, and H remind you of? So we know that the gradient would just be like the blue thing over the black thing over here, the change in y with the change in x. But there's another way of thinking about this. This is trigonometry, yes. And what is the ratio for O over A? What is the trig ratio for O over A? So it's tan, yes. So there is a new formula that we need to be aware of. And this is the angle of inclination formula. And what it says is the gradient is equal to the tangent of the angle of inclination. So I'm going to start now with a straight line that has an angle of inclination of 60 degrees. So let's say this is 60 degrees. I want you to use the formula m equals tan theta to tell me what is the gradient of the blue line. So take out your calculators. I'm going to tell you that the gradient is 60 degrees, or the angle of inclination is 60 degrees. So that's the angle between here and here. I want to know what is the gradient, and I want you to use this formula here. What am I going to need to do? I think in my calculator, I should just put the tan of 60, and then I will get the gradient. So tell me, what do you get in your calculator? Pop it in the chat there. Ah, Naledi, Buchle are saying root 3. And Callan agrees. So I think you guys are off to the races. So going forward today, we are going to be using this formula in lots of drawings. And so let's just do that because it's really not too bad. So here is, let me give you another one. Here is, I'm going to make up my own question. This one, the angle of inclination is going to be 80 degrees. I want to know what is the gradient of that straight line. what is the gradient of this straight? Now, it looks steeper to me, so the gradient should be bigger. But I want you to tell me in the chat, what do you get? What's the gradient if the angle of inclination of this line is 80 degrees? So in your calculator, you're going to put the tan of 80, and you get 5.67. And what that means is on this line, for every 1 unit I go across, I go up by 5.67. Okay, fantastic. You guys are smashing this. Now, this one, the angle is 135. Now, 135 actually gets me to this side. So my angle of inclination is going to be this. Now, I want you to figure out what is the gradient of this blue line if the angle of inclination is 135. What do you get? Well, it looks like the same formula should work. And what do we get? We get -1. All right, that's actually quite easy, I think. Give me a happy face if you think that was quite easy. Give me a sad face if I lost you there. But so far, this angle of inclination doesn't seem too bad. Let me see the emojis for a second there. Okay. All right. Now, let me go the other direction. So if you have a straight line with a gradient of 5.69, that is going to be positive, and it's probably going to be quite steep like that. Now, what we need to do is we need to see, can we use the formula to go backwards? I want to know, what is this green dot, the angle of inclination for this red line? What do we need to do to get, it feels like I should put 5.69 there, but now the theta seems to be locked away inside the tangent. What do I do to get that theta all by itself? So I think we need to use what's called the inverse tan. And if we apply inverse tan on both sides, on this side, it basically will undo the theta. And then on this side, it would be applied to this. So I get theta on this side. What angle am I getting? I'm getting 80.03. So that's perfect. So my angle of inclination will be 80.03. So this formula also works backwards, which is good to know. Are there any questions or comments about using inverse tan? I have to go shift tan to tell my calculator this is the gradient. Please give me the angle of inclination. All right. I'm assuming that there are no further questions, so I'm going to keep going with another example. Determine the angle of inclination for a line with the gradient 4/5. I'm not even going to do a drawing for you this time. I want you to just tell me, what is the angle of inclination? You work that out, you tell me. We don't even need a drawing for this. I will give you the formula if you like. So I'm going to put 4/5 here. And then I have a trig equation that looks like that. What am I going to get for theta? My angle of inclination is going to be, so shift tan 4/5 And Zasipo, Bukle, Sylvester are all telling me 38.66, or if I round it off to the nearest degree, 39 degrees. Okay, still not feeling too bad. So this is kind of interesting. All right, that's that one there. I want to look at this situation here. Okay, now I want to work out what is the angle of inclination of this straight line. But the problem is they give me this funny drawing. What do you think I need to do first before I can start to work out what this big blue dot is going to be? What do you think I need to do first? All right. Sisipo suggested the gradient. I think I like what I'm hearing there. Bukle, what do you think? What would you start with?
Well, at school, when we're dealing with problems like this, we usually
Yeah.
start finding the angle on the inside.
Okay. So if you were going to find the angle on the inside, which would be here, I still think you're going to be a bit stuck because you would have to get this green one before you get the blue one. So I agree. Sometimes you're right. In these questions, these sort of, if there's an angle hanging out here, it sort of relates into the triangle. But for now, I don't know if you would agree with me, Bukle, but if I could find the gradient, would that be helpful?
Yes, it would.
If you were going to try and find the gradient, could you do that? Where would you start?
Well, we do have two coordinates.
Yes. And in fact, this one
So,
over here, its coordinate would be 0, 2.
yes,
So
sir.
I think, okay, so perfect. So actually, I'm going to do this with you because I think I'm feeling pretty confident now. So I go 0 minus 2, and then I go 6 minus 0 minus 2 over 6, or minus 1/3. Okay, so we have our gradient. Now, okay, thank you, Bukle. I want to know, what is that blue angle going to be? I want you to try and work it out using this formula. Now, some of you might be getting quite a strange answer. Don't worry if you are. Let me know what your strange answer is. Is anybody getting a minus sign when they go shift tan minus 1/3? Yep, you're getting a negative angle, and I'll explain in a moment why that is. But I just want to know for now, what are you getting as your angle? You should be getting a negative. It's a little bit, this one's a bit more tricky. But I'll explain now why. So minus what? So shift, I'm going to do it with you. I've got my calculator here. So I'm going to go shift tan, and then it's going to be minus 1/3, close bracket, equals, I get minus 18.43. Now, the problem is, I can visually see that that angle minus 18.43 is not the blue thing that I want. Now, this is a bit of a trick with this type of problem. If you have a negative gradient, so if you have a negative gradient and you are using this formula, it gives you the smaller of the two possibilities. So what the calculator is doing is it's giving you the size of this angle over here. So the line makes two angles with the x-axis. There's the big blue one, and then there's the smaller red one. And because it's going in this direction, it's going to be minus 18.43. So we need to go from this red one and somehow get to the blue one. Now, what do you know about the blue and red one added together? What are the blue and red one together going to give you? What is this blue and red one actually on? 180. Perfect. Now, if you want to get the blue one from the red one, all you need to do is take the minus 18.43 and add 180 degrees to it. And what that will do is it will give you the blue one. So when you are dealing with negative gradients that are negative, you won't get the angle of inclination straight away. You have to go, either you ignore the negative and go 180 minus, or the simplest way is just to go add 180. So what is the size of the blue dot going to be? What's the angle of inclination for the blue dot? What's the angle really going to be? And we'll do another one like this in a moment so you can get used to it. So I'm going to use my calculator and I go plus 180 and I get 161.57. And that makes, if I look at this visually, this makes a lot more sense. It's going to be 161.57. And the angle of inclination is always measured from the positive x-axis in this direction. So this is something a bit new that we need to practice another example of, but I just want to summarize it for you. When you find a negative gradient of a line and you're finding the angle of inclination, when you use this formula, your calculator is going to give you the smaller angle, not the big angle that is made between the line and the x-axis. In order to go from the small angle to the big one that you want, you simply have to add 180 degrees. And that is it. So I want to do another example like this to end tonight, just so you get a chance to see another one. Okay. Let me find another negative one. Okay, here it is. Last question for tonight. You need to find the angle of inclination of this line. Step 1 is going to be to find the gradient. Step 2 is going to be use the formula. I want you to find me the gradient of this first. And then we'll talk about what is the angle of inclination of this blue line. What is the gradient of this? So we go -3 minus 1 over 5 minus 1, which is -4 over 4, which is -1. Now I have this formula, but I need to be careful because I've got a negative gradient, which means there are two possible angles being formed between the straight line and the x-axis. There's that one, I'll call that the red one, but there's also the green one, which I'll call that one there. So when I put this into my calculator, I'm going to get theta is -45, or it's basically going to be this angle over here. What is my final angle of inclination? What is my final angle of inclination? It's not going to be -45. So I just need to take my -45, add 180, and I get 135, which when I look at this, it looks awesome. So in recapping today, we spoke about perpendicular lines, we spoke about parallel lines, and we spoke about the angle of inclination that lines can make. We also looked at how when a line has a negative gradient, there's an extra step that we need to do in order to get its angle of inclination.